In this lesson, we will use a Poisson distribution as an approximation to the binomial distribution. And we will see when this approximation is valid. In the diagrams here, Poisson and binomial distributions are plotted on the same graphs for various values of their parameters. The Poisson distribution is with purple and the binomial with blue. As you see, in some cases, it's quite a difference between their probabilities. So in this case, I can't use Poisson to estimate binomial. In this case, they are closer, whereas in other cases, they are very close to each other. Even though here they look to be the same, in fact, they are not. They are different distributions. However, as you see, they get so close to each other that I can use Poisson to approximate the binomial distribution. So when is the case when I can do this? To be able to see better, this example was chosen so that the mean for the Poisson distribution stays 4. The parameters of the binomial are changed. Look at P. When P gets smaller and smaller and smaller, the approximation is bigger. So P needs to be very small and N needs to be bigger. So when N is big and P small, the approximation is good. So let's look at X as binomially distributed with NP, and let's call Y the Poisson distribution with a mean lambda. When we calculate probabilities, if we want to use Poisson instead of binomial, we can do this when N is big and P is small. What means N big? It is taken as a rule N bigger than 50, then N is big. How small should be P? We are going to express a condition not in terms of P, but in terms of NP. When NP is smaller than 5 and N is bigger than 50, the approximation is good. As you see here, Q, which is 1 minus P, does not appear because if P is very small, then Q is close to 1. So NPQ when Q is close to 1 is pretty much the same as NP, and the condition is fulfilled. Therefore, we'll remember that when N is bigger than 50 and NP is smaller than 5, then I can use Poisson instead of binomial. Now, you would know the binomial. Let's assume you know binomial NP. You check N is bigger than 50, NP is smaller than 5. Then the question is, okay, I can use Poisson instead of binomial, but what is lambda? Of course, if Poisson and binomial are approximation to each other, they are close to each other. So therefore, the mean of the Poisson needs to be the same as the mean of the binomial, if they are so close to each other. So the mean of the Poisson distribution will be the mean of binomial, which is NP. So lambda is NP. Some people tend to learn this by heart. I don't, because it's logical that the mean of the approximating distribution needs to be the same as the mean of the distribution that we approximate. In examples, you are going to be asked to use Poisson to estimate binomial. So this is going to be made very explicitly. If you remember from the S1 course, we used normal distribution to approximate binomial. That made a lot of sense, especially when I had to add many probabilities for the binomial, and therefore I used less calculations using the normal distribution. In this case here, when we use Poisson to estimate binomial, there is not such a case. So at our level, we don't see yet the use. So how using Poisson to estimate binomial makes our calculation easier? They will not make them easier. Why is this lesson here is purely from the theoretical point of view. We look at the distribution theoretically.